Tonight, we will talk to you step by step about choosing the right transition technique for IPv6 deployment. Before continuing, we would like to know which country you are joining us from. So I will ask you to tell us in the chat section where you are. Okay, so we have people from Nigeria, Egypt, Cape Town, Cape Verde, Suzette, Nigeria. Great. So I think people will start joining in. So now we're going to get to the heart of the matter. In order to ensure the success of this webinar, let me give you some house rules. First, go to menti.com, menti.com, menti.com. We will be using this platform later during the webinar. And all the controls are at the bottom of your screen. For any questions related to the webinar, please use the Q&A section. For all other needs, technical problems, slides, sound, use the chat section. At the end of this webinar, we will be sending you a survey. This will help us improve our future presentations. So please don't forget to complete it. Also note that this session will be recorded and we will make the video and slides available to you after you complete the survey at the end of the webinar. For this evening, our presenters who will be speaking to us are Bashir Angode, he's a trainer at Afrinic, and Jody Pallet. To ensure that you have a smooth experience, we have Olatunde, another trainer of Afrinic, who will be providing support in the background. We look forward to a fruitful, enjoyable, and above all, interactive session. The mic is yours, Bashir.
Thank you very much, Emma, for that wonderful introduction. And I'm really happy to have you guys with me. And today, as Emma mentioned, we'll be talking about how to choose the proper transition technique. With me, I have a popular guest, very popular. Some of you might know him. And if you don't know him, I like to give Jody the floor to briefly introduce yourself.
Hi, everyone. Very quick introduction. I have been working in IPv6 training and deployment since 2001, more or less. I have participated in many trainings for Afrinic and other registries, and I'm happy to help. Simple like that. We have done a lot of deployments for customers worldwide. I think I have participated in projects in more than 140 countries, just for a quick reference.
That's great. I think those are brilliant credentials. So, and we are glad to have you here, right? So hopefully you're going to share with us what you've experienced as you help operators deploy IPv6 and with these transition techniques. So we like to make this session interactive, right? So feel free to always chip in the chat section. If you have an experience deploying some transition techniques, we like to hear from you, because I usually believe that as much as we are giving the knowledge, it's also good to learn from you. You might have experienced something that is beneficial to everyone else. So feel free to be interactive, Q&A, ask questions in there, and it will make the session much better. So our agenda today will just be looking at transition techniques, how to choose the right transition technique. And before we choose, you need to know why we need transition techniques in the first place. And then once we know why we need the transition techniques, we're going to look at an overview of transition techniques that you're most likely to implement in your network in this day and age in 2021. Then once we look at that, we're going to look at which transition techniques you should use in your network. Of course, this question is usually, there's no one size fits all. There are a lot of factors that will depend on your choice of transition technique. But we're just going to give you recommendations which will at least help you in choosing a transition technique. Then finally, we briefly look at auditing. How do you do an audit, and end with a Q&A. So before we look at why we need transition techniques as our first objective, So I usually have this question. Sometimes when you're discussing with people, some people will tell you that we are migrating to IPv6. And to me, I usually know it's transition, because when you talk of migration, you're moving from V4, where you are now, to V6 and abandoning V4 completely. But that is wrong, right? When you talk of transition, as much as you'll deploy IPv6 in your network, there still needs to be some sort of coexistence between IPv4 and IPv6 till the point where we've all deployed IPv6 and everyone can run on V6 only. But for now, we need to have the coexistence mechanisms or these transition techniques. So to understand where we've come from, right? In 1981, that's when we had IP as a protocol being designed. And then if you look at the timeline, in 1994, if you read RFC 1631, I won't read everything, just the first line. So this was in 1994. The two most compelling problems facing the IP internet are IP address depletion and scaling in routing. So remember, this is in 1994. This was in 1994. So sometimes we have this idea that these transition problems, you might think that they are very new, but they've been there since when the internet was growing, and it was foreseen that IPv4 was not going to cut it in the long run. So you can see in 1996, that's when we had RFC 1918, and these are what sometimes I call band-aids, because they just help prolong the lifeline of IPv4. RFC 1918, these are private addresses in conjunction with NAT. And then in 1998, we have IPv6. So the discussion from IPv4 to IPv6, so there are two options. There are some options which were looked at, right? So either we could have made the new protocol, since we identified the problems with IP, right? IPv4. So the new protocol that was to be a replacement of IPv4, so there are two options: either come up with a compatible protocol with IPv4, or come up with a totally new protocol, but with more features and much more extensible. So the decision was to go the IPv6 route, a new protocol. And the reason behind that is, even if you create a protocol that is compatible with IPv4, there still needs to be some sort of upgrades that will be done on hardware, right? So if you're going to do upgrades, why not just move to the new protocol that is much better? And that's why we have IPv6. So since 1998, when you have IPv6, I think in the year 2000, we had the first, if I'm not wrong, the NAPT, network address with translation, port translation in 2000, which had its own issues. But already from back then, you can see that coexistence between IPv4 and IPv6 was already being looked at. So how do we have these protocols running together up until a point whereby we can have the new protocol being deployed massively, and we can move away from the old protocol? And basically, that's the need for transition techniques, just the need for coexistence between these two protocols in the short term as we move to the newer IPv6 protocol. Yeah, so this is just a summary of what we've discussed. So maybe my next question will be to Jody, because sometimes when I meet with some operators, they'll tell me that, why do I need even IPv6? I can do CG-NAT, we still have addresses. My customers are not even asking. So maybe Jody, from your perspective, what are some of the disadvantages behind using NAT, CG-NAT to be specific?
Okay, well, the first question is to explain or to clarify a confusion that most of the people have about what is CGN or CGNAT or carrier grade NAT. All those are terminologies used by vendors, and those are commercial terminologies. The right terminology in IETF documents is AFTR, okay? address family transition router. That's the right terminology for this device. So the other thing is just vendors commercials. What is carrier grade NAT? Carrier grade NAT is just a big NAT44. Okay, so the same way you do NAT in your CPE, you can do NAT at the carrier scale. Okay, and what happens is that carrier grade NAT is not a long-term solution, but because even if you use carrier grade NAT, you cannot use this forever if your network keeps growing, because you will not have even sufficient private addresses to run that. Okay. The other problem is that people believe that carrier grade NAT is expensive, and it's true. And in general, what happens is that there are better technologies like IPv4, IPv6 only, and IPv4 as a service that we will look on the rest of the presentations, which are much cheaper and more efficient, and they are long-term solutions compared to carrier grade NAT. Carrier grade NAT break things. There are many things that can be broken. You can have sometimes ALGs, application level layer gateways, to resolve those. But in general, using carrier grade NAT means increasing OPEX and CAPEX. There is additional implications, like, for example, the cost of logging, which it can be very expensive. It depends on how many months or years the regulation of each country is asking for. And the bigger problem is that many people don't realize that if you have, for example, residential customers running PlayStation network don't work with carrier grade NAT. So what they do is they put the IPv4 addresses of the carrier grade NAT in blacklist. So that means that all your IPv4 pools will become part of the blacklist, and you will need to buy more addresses. So if you really are considering buying carrier grade NAT, it will be cheaper for you to use the transfers to get more addresses. Okay, that's basically it. What that means at the end is that it actually don't make sense to use carrier grade NAT. Either you use just more IPv4 addresses, or you think in a long-term solution, which is IPv6 only, with IPv4 as a service.
Yeah, that makes sense, because in the long run, businesses are there to make money. And if you look at long-term goals and targets, it makes sense not investing in CGNAT, but moving towards IPv6. So thank you for that, Jody. Next, we'll look at the our first poll. So we have our first question. So head over to menti.com, and we just like to know menti.com, and then enter this code 137-328-72. Menti.com 137-328-72. And we just like to know, from your perspective, what stage are you in regards to IPv6 deployment? You don't have plans, you're still planning. You've advertised, at least advertise your prefix. You have your core on V6. Then you have customers on V6. So only one person in here. Okay, 2 people, customers on V6. So you can see more responses. So menti.com, what stage are you in with regards to IPv6 deployment? Should be more than 60. So I'm just targeting half of us at least, and then we can move on. So at least most of us have started working on V6, which is good news. And in close second is people with no plans to do V6. So I hope by the end of this session, we're going to have more, with the knowledge that we'll share, it's going to be easy for you to make a decision to start transitioning to, or to start deploying IPv6. And I can see no plans is winning So hopefully by the end of this session, once we give you our views on these transition techniques, if we decide to redo this question again, maybe if you ask it in a different way, we'll have more people willing to move to V6. So thank you for your feedback. So the first thing that we're going to look at, now that we've looked at the reason why we need transition techniques, so we're going to look at the transition techniques themselves. And our scope will fall in this set of transition techniques. So we'll start by looking at dual stack, and then the rest of the transition techniques assist in what we call IPv4 as a service. So majorly, you'll start by deploying V6 and V4 together in your network, right? And then the next step is having V6 in your core and running V6 on maybe the customer's end. So this is the scope of our presentation today. So we'll start by looking at dual stack. And basically for dual stack, it just means that you're running both IPv4 and IPv6 protocol stacks. And sometimes I can equate it to if you're trying to speak English. If you speak English and you want to speak with someone who speaks Arabic, so you need to learn English, which you know, and then on top of that, learn Arabic so that you can be able to speak with these two sets of people. So dual stack is the same. But remember, just because a node can be configured with an IPv6 address, it doesn't mean that it has full dual stack support, right? So there's some features which you need to check and see. So if you're doing routing, just because you can configure an IPv6 address on that box, it doesn't mean that this device supports all the features that you want. So you need to look at the features side. And then in dual stack, it relies heavily on DNS. So when you're talking on the host perspective, so how does a host determine which protocol stack to use, V4 or V6? So it relies on DNS. I'm going to show you a demonstration in a short while. But another main problem with the dual stack, you still need V4, which and these resources are scarce, right? V4 resources are scarce. Only Afrinic has a pool of readily available IPv4 addresses, less than 1.8 million the last time I checked. So when you're doing dual stack, you still need V4 resources, which is a drawback. And then there's an RFC called Happy Eyeballs, which just enables helps to prevent user visible delays when running dual stack. So let me show you how it works quickly. So the first thing that is done, the host on the left is trying to access www.example.com. So the first thing that is going to do is send a request, DNS request for a code for an A record, that's V4, and a code A record. And this request will be sent concurrently. Then the DNS server is going to respond. If there's an A record, it will respond with the A record. If there's a code A record, it will respond with the code A record, right? So also another aspect to this, you might have configured dual stack on the end device, but you don't have a code A entry to the server, or the server doesn't have V6. So only the V4 is going to be used. So once that is done, the next thing that will happen is the TCP SYN, connection establishment. So we're going to send a SYN with you're still using both protocols, right? V4, V6, and these happy eyeballs working. Because imagine if one of the protocols is given priority of the other one, even though V6 is given a slight head start, but we still do the concurrent connection establishment so that the user doesn't notice if there are any delays. And then, of course, the server will receive the SYN and reply back with the SYN ARCs, and then the client will reply with the ARC, and the connection is established. So basically, dual stack relies heavily on DNS to achieve its functionalities. And then you can always look at happy eyeballs. When you review the slides, you look at the RFC, which will explain further how these improvements have been done to prevent user visible delays to the client. But dual stack has some benefits. Of course, it's at first sight, it's easy to roll out, right? All you just need to do, as long as your devices support IPv6, have the proper support, you just need to enable IPv6 and enable the various protocols that you're running or the various features that you are running, as long as there is support, right? And then once you've enabled IPv6, you'll have IPv4 and IPv6 running concurrently. So IPv4 does not impact IPv6, IPv6 does not impact IPv4. But there's a problem. Like we mentioned earlier on, the first problem is you still need more addresses. And then you're going to have additional work in terms of monitoring. You need to monitor those both protocols. Troubleshooting, you need to, it's a factor when you're troubleshooting. And also security policies. Right now you're running on v4. Once you start deploying IPv6, most of the time, sometimes you might forget to have the same security policies that you have in v4 to also apply to v6. So these are some of the pros and cons. And of course, like Jody mentioned, you still have the element of NAT, which again, additional OPEX and CAPEX, and you still need more IPv4 addresses.
If I
So
can say, if I can say something else, Bashir.
Yes. Yes.
One problem of running dual stack is that you have IPv4 addresses configured everywhere, and that means that you are using more addresses. So even if some parts of your network don't have any more IPv4 traffic, you are still using the addresses because are configured. Okay, so somehow you are wasting addresses unnecessarily. So dual stack was a good solution a few years ago when we didn't have IPv6 only with IPv4 as a service, but today is not the smarter solution.
Okay, thank you, Jody, for those inputs. But maybe what about, let's say if you have a team of engineers that are not yet comfortable with v6, is it correct to say that it may be, at least for a starting point, for them to at least get used to IPv6 and at least start the deployment, as much as it's not the end, it's not the best thing to do looking at the long run, right,
well,
Jody?
The point is that my recommendation is always on the end sites, on the end VLANs, like for example, your office, your home, even in the data center, if you still have IPv4 addresses, use dual stack. In those places, you really need to try to keep dual stack. What I was mentioning is in the network. As soon as you get rid of IPv4 addresses in the network, I mean in the core of the network, in the access network, in the distribution, as sooner as you are improving or reducing your operational expenses, your OPEX and your CAPEX, because those addresses can be used in other parts of the network where they are essential. But yes, to get comfortable with that, in the VLANs for the engineers, it's good to have dual stack, of course.
Great. Thank you very much for your response. So next, we'd like to look at just a quick poll. And it might be very straightforward, right? But sometimes we have challenges with this. People do not want to move to v6 because of this question here. Does enabling dual stack mean double memory and CPU? So head over to menteecom. It's a quick yes or no answer. Does enabling dual stack mean double memory and CPU? So I can see, okay. So we have a tie. The yeses are having it. So it's a yes or no answer. Very quick to make your selection. So do you think that by enabling dual stack, let's say in the router that you have, does it mean that you're going to have double utilization? For example, right now, if your CPU utilization is at 10%, are you going to get to 10? Are you going to get to 20, 30% if you enable dual stack? So I can see most of us are saying yes. And I'd like to take this opportunity to ask Jody to give us his comments on this. So when you enable dual stack, does it mean that you'll be utilizing double memory and CPU from what you have currently?
Actually not. What happens is that many people believe that dual stack means totally doubling the cost of the memory, resources, CPU, etc. But it's not like that, because it's not meaning that you are sending all the traffic in both IPv4 and IPv6. The traffic is sent only in one of the protocols. Typically should be sent by IPv6 if both destinations, if both source and destination have IPv6, and will only fall back thanks to happy ables to IPv4 if IPv6 for whatever reason is slower, okay? Now, if you look into the cost of the stack today, a stack cost in terms of memory consumption, no more than 20 kilobytes, okay? So it's really a small stack today. If you have a dual stack, actually it's not doubling it, because it's what we call an hybrid stack. So you have some additional things, because TCP and UDP are exactly the same in IPv4 and IPv6. So you have only 10 or 15% increase, but it's not increasing it's not decreasing performance. It's not increasing the cost of CPU. It's basically only a small increase in the storage of the stack itself, but it's just 10%. So it's ridiculous. It don't make any problem in a server or in a host, not at all.
Okay. And what about, let's say, these IoT devices, smaller, very small devices? What can you say about this? Do this support V6 only?
Exactly. That's the idea. Real IoT means IPv6 only. When the vendors say IoT with IPv4, that's not really IoT. That's amazing, because you cannot have millions of devices with IPv4. There is no way. So it's just a marketing thing that they call IoT to something that has IPv4 only. IoT devices, in fact, there are many protocols for IoT that don't support at all IPv4. Like, for example, 6LoWPAN, which stands for IPv6 for low-powered devices. So definitively, IoT is just IPv6. If a vendor tell you IoT with IPv4, that's not IoT. That's, let's say, trying to be IoT, but it's not correct.
Yeah, makes sense. So let's go ahead and look at the next transition technique. We've looked at dual stack. So let's look at, if I can call this transition technique the bigger brother or sister to dual stack. So this is dual stack Lite. So basically with the dual stack Lite, you remove IPv4 usage in the core of your network. And then you're going to combine the use of tunnels and NAT to provide connectivity to the end devices or to the customers. And basically it has two elements. I'll review this quickly and then I'll show you the diagram with all these components all together. So it has the bridging broadband element, or the B4, and the address family transition router, the AFTR. So the B4 is just the CPE. Then the AFTR is what does, you can even picture what does NAT currently, CGNAT currently. That's the AFTR. And then, of course, the tunnels are going to provide a direct connection between the B4, the CPE, and then the NAT device or the AFTR device. Of course, as with the usual dual stack, we still have some cons whereby you still have IPv4 address sharing, but it's much better than a dual stack. So let's see how it works. So basically, your core will be V6 only. So you have V6 only in the core, right? And then the B4, this is the element that is in the customers. This is the CPE. So when a packet is being sent from the dual stack device down here, so this packet is going to use, since we have V4 and V6, no translation, no tunneling is going to be done. So we're not going to have any tunneling. So going down to the IPv6 internet. But for V4 only devices, for whatever reason, So these are the devices that are going to use the tunnel. They're going to be tunneled in V6. So the packet will be sent to the B4 device. And then the B4 device is going to encapsulate that packet in V6 and send it to the AFTR. And then the AFTR is going to decapsulate the packet and send the packet as V4 to the IPv4 internet. So that's the basic functionality of dual stack Lite. So combination of tunnels, and then also we have carrier grade NAT happening at the AFTR. Then the reverse holds true. When a packet comes from the internet, it's going to be encapsulated, sent back to the CPE at the end. So of course, this translation technique has some cons, right? So the pros of it, as we mentioned, it's one step up from dual stack. It's much better. Then the main con is, the main disadvantage is it maintains per flow state. So what do we mean by per flow state? So let me go back to the diagram. So if this is a CPE and you have several devices connected to this CPE, so the CPE up here, let me use the V4. So you're going to have several connections from this device. Let's say you've opened a browser, the browser has several tabs, things like that. So at this device here, it's going to be monitoring. It has to maintain the state of each and every flow. And the flow basically should be the combination of the source address, destination address, source port, destination port, and then the transport protocol or the protocol, right? So when you talk of the AFTR maintaining per flow state, and this sometimes is needed for legal reasons, right? You have to maintain all the customer information in your network. And then also you have lots of tunnels or the softwares. So whenever you're using the tunnels, imagine if you have 1,000 customers. So each of those they're going to have various tunnels connecting the B4 to the AFTR. And then you have limited number of ports per subscriber. So when you're provisioning this, you're going to say each customer is going to have a certain limited number of ports. And if there are a lot of users behind the CPE, it can impact performance. So the next transition technique, so we've looked at DS Lite. The next transition technique is lightweight 4/6. So lightweight 4/6, it's similar to DS Lite, and it combines tunneling plus NAT. Remember DS Lite, V6 only core, then you have the B4, and then you have the AFTR, right? In the provider's network, inside the provider's network. So similar, everything is the same. But the difference is we move the address protocol translation, network address protocol translation from the AFTR to the CPE. So instead of doing NAT on the AFTR, we do it on the CPE. And this one brings about some benefits, right? So the first benefit, it means that in terms of logging, you're not going to be doing a per flow logging. You're going to be doing what you call a per subscriber logging, because the state is only maintained at the subscriber end, at the CPE, right? So essentially, lightweight 4/6 reduces logging. And then it has two elements, just the same as a DS Lite, but this time around we call them the lightweight B4 and the lightweight AFTR. So how it works? Same way as DS Lite, packet is sent V4, V6 only goes straight ahead. No tunneling is done. And then when you're doing V4, so when the packet gets here, it's going to be translated at this point, the NAT translation from the private to public, and then tunneled over V6. And then once it gets at the AFTR, it's going to be sent directly to the internet. So with the lightweight 4/6, it makes it much easier, and it's much better than dual stack Lite. So I think if you're to choose between DS Lite and lightweight 4/6, lightweight 4/6 wins it. So of course there are pros and cons. It's better than DS Lite. It reduces since you have reduced, you are maintaining the per flow, not per subscriber state. So there's reduced logging. But of course, similar to DS Lite, you still have a lot of tunnels, limited number of ports per user, and then it has lower capex. And it's at this point based on the lower capex, Jody. So I'd like to get your views. When you talk of lightweight 4/6, so you talk of DS Lite, right? And then lightweight 4/6, which is like an enhancement to DS Lite. So what does it mean when you talk of lightweight 4/6 having lower capex than the other transition techniques?
Yes, actually, both dual stack Lite and Lightweight 4/6 have a bigger capex than other possible solutions. We will see that across the rest of the presentation, but it's correct that Lightweight 4/6 has lower both capex and opex. Why? Because OPEX in terms of less logging needed per subscriber, less cost of logging per subscriber. And in terms of CAPEX, because usually the AFTRs are cheaper, or even if they have the same cost, they perform better. Okay, so if you have the same box being used for DS Lite, it will have lower capabilities compared with Lightweight 4/6, because in Lightweight 4/6 don't need to keep all that state. It's more stateless. That's the difference. Now, the problem of both of these protocols, and that's somehow CAPEX, is that you still need a lot of IPv4 addresses. And the most important against these protocols is that you are limiting the number of ports per customer. So for example, in a household with 4 or 5 people in the family having 4 or 5 devices, if they open just something like Google Maps, they will not be able to see several Google Maps screens at the same time if they have only, for example, 2,000 ports, okay? Because more and more applications take advantage of what we call Ajax to multiplex the different parts of the browser or the application in general using more ports. And of course, you are reducing the number of ports to be able to share more addresses, less addresses with more customers. So that's the difficulty of both of them.
Yeah. And I think also because as I was looking around, we have open source implementations of this, the AFTR, Snub, and even Juniper for the implementation of Lightweight 4/6. They do it via VMX,
yes,
packaged with Snub.
However, we tried that a few years ago, and was not really a good implementation. It was performing really, really bad. I don't know if it has been improved in the last 3 or 4 years, but it was not really a good implementation.
Yeah, that's
it's
good
not,
to know.
I mean, it works, but it don't work if you have thousands of customers.
Great. So thank you, Jody. And the next transition technique is MapE, which we're going to look at. So still tunneling. So this is the mapping of addresses and ports with encapsulation. So whereby you'll map IPv4 addresses and ports, and then do tunneling over your V6 only core. So similar to Lightweight 4/6, we still have the 2 elements, but this time around we call it the border relay. So this is in this provider's network. So if you are to match what we had in the other transition techniques, the BR or the border relay, this is the AFTR. And then we have the customer edge MapCE, so which is at the customer's end. And it provides tunnels for a direct connection between the BR and the CE. So similar to how the previous technologies work. So this time around, we still have NAT44 being done at the CE level. V6 goes straight to the v6 internet, no need for encapsulation. And then v4, so as usual, it hits the CPE and then it's going to be translated. And then there's sort of a mapping table. So the mapping table is at the BR, the border relay. So where you do the mapping of address plus ports. So it means that in this solution, state is only maintained over here at the CE. You don't maintain any state at the BR. And then the packet flows through the v6 only network to the internet. Then the reverse is the same. So the pros and cons of this transition technique. So it's sort of like a stateless DS Lite. Remember, for DS Lite, the state was being done in the AFTR, right? And then this time round in the BR, we don't have any state. So it's stateless. So we just have the mappings. And then we still have IPv6 only towards your subscribers. And then you can monitor v6 only. But the disadvantages with this, and later on, you're going to give us more insights, right? But you can see we still have the same disadvantages as what we had with lightweight 4/6. It's still tunneling, right? So you end up having a lot of tunnels, which is overhead in the BR. That's the device in the provider's network. And then, of course, you still need more IPv4 addresses. I think we've mentioned this. And the issue of ports, we still have it because you have a limited number of ports allocated to each subscriber based on particular IPv4 addresses or addresses. And the same thing, additional OPEX and CAPEX. I think Jody mentioned this when you talked of lightweight 4/6, same thing. Then we have the alternative translation, MapT, mapping of addresses plus ports, but with translation. So it's similar to MapE, but instead of doing encapsulation or tunneling, we do translation. So at the CE, we do translation from V4 to V6, and then at the BR, we translate from V6 to V4. And then we have the mappings of ports, addresses plus ports at the BR. So as usual, same narrative, V6, no translation, straight ahead. V4, we do translation 4 to 6 at the CE, and then the packet is sent as a V6 packet inside the core, and then we translate from V6 to V4 at the BR onto the internet. So at this point, Jody, I'll ask about these two protocols, MapE and MapT. So we've looked at DS Lite, lightweight 4/6, and then MapE, MapT. So any experience on these two protocols, operators deploying them?
Yes. Okay. Let me explain a little bit the history of the four protocols. Actually, DS Lite, lightweight 4/6, MapT, and MapE. The first protocol that was implemented in IPv6 was DS Lite, and DS Lite got a good traction in links initially. So there were many operators in both Asia Pacific, US, and Europe that used DS Lite. Then we realized that we can do it much better with lightweight 4/6. But unfortunately, that was happening at the same time as other protocols such as 464X LAT, which are getting more traction. We will talk about that later. Then there was a fight in ITF because some people were saying MapE was better than MapT, and some people were saying on the other way around, okay? And the original idea was to standardize only one of those, MapT or MapE, and at the end, both of them were standardized. And both protocols were designed somehow by the hands of one of the bigger vendors, which starts with C. I am not going to say the name, but everybody knows who I am talking about. To be honest, there has been no traction. It's true that there are some deployments in Europe, very small, and some deployments in US, but there is not that much traction in the market as it was expected. We did some trials with customers using several protocols. And the big problem of all these 4 protocols, I mentioned it before, again, DS-Lite, Lightwave for Overseas, MapE, and MapT, is that you still need a lot of IPv4 addresses. And because you are using sharing of addresses fixed by customer, it means that you have limitations in how you manage the customers, and some services, like I think I mentioned it before, Sony PlayStation, they block your addresses. So if they block your addresses, you need to rotate the addresses, all your IPv4 addresses, in those border relays or CGNs. And that means that you run out of addresses. So in that sense, it don't make sense to invest in these protocols. It makes sense to go straight to invest in more addresses, right? It's no meaning. So that's basically the problem. Now, with MapE and MapT, there is one additional question, is that the protocols define a kind of new addressing space, which is, instead of 32 bits for IPv4, is 32 bits plus the 16 bits of the port numbers, because they are limiting the number of ports per customer. So you have a new kind of address, which is a 48 bits address, and that means that you need to define the addressing plan for your network depending on the protocol itself. And I don't think that's good, because the good thing of doing in a human way, let's say, an addressing plan, is that you will really optimize your address space as much as possible for your specific network case. So this is the worst thing, in my opinion, for these 2 protocols, that they are fixing for you the addressing plan for IPv4 and for IPv6, and that's not really good. Again, it's my personal opinion, and my experience is most of the people, when they try different protocols, they reach the same conclusion. None of those 4 protocols is the best solution. And I think when we finish today, most of you will have about the same impression when we understand how the others work.
Yeah. And the reason I asked also this question, when I was doing my research, I noticed one of the providers, I will also follow your cue, right?
Yeah.
The name starts with J, and they recently just implemented MapE, and they don't have implementations of MapT in their devices. So yeah, so that's why to me it seemed like
there is one additional problem. I just remember about that. There is one of the bigger implementations on the wall in IPv6 is a company in India called it a service provider in India called it GeoReliance. Okay. They have been able to reach something like 72% of IPv6 traffic in India because just this big provider. Of course, India has 1.4 billion inhabitants, so it's a big country. So they started, I don't remember if it was MapE or MapT. They started with that protocol, and they had a problem with the regulator, because the regulator in the logging requirements, they were asking to record a certain number of parameters for every connection, and these protocols, because this advantage of stateless, they don't provide these details. So the regulator said, no, this protocol is against our regulation, so you cannot deploy it. So using MapE or MapT in some countries may be against the law. It's ridiculous, but it's like the law is made.
Yeah, that's interesting to hear. So just to check up on our participants. So I just want to see if people are still with us and attentive. So the last Menti, before you move on, go head over to menti.com. Menti.com. And the question is, where is not done in lightweight 4/6? Where is not done in lightweight 4/6? So 8 people, 12. So no one is choosing the B4 at the end. So this is going to prove if indeed what we've been talking about with Jody, if we've been listening at least. So we need to see more people with the right answer. So I think that's good so far. So the answer is the lightweight B4, right? So that's where NAT is done in lightweight 4/6. So we're going to share the slides and recommended RFCs, and you're going to read, you can look at more details on these transition techniques. So thank you for your participation. Let's move on and look at a recap of NAT64 before we look at 464 XLAT, because that's our next transition technique. And somehow this is a component of 464 XLAT. So when you talk of NAT64, so it enables the communication of V6 only to V4 only communication. And basically it does two functions: translating the headers according to the IP-SCMP translation algorithm. We'll leave the RFCs later on. And basically you translate the headers. Remember you have V4. The V4 header has 14 fields, if I remember well, can't remember. The V6 field, the V6 header has 8 fields, right? So there's the version, source address, destination address. So when you're doing the translation, these addresses these headers also need to be translated. So V6 to V4. Then the other function is the translation of addresses. So to translate addresses, we can use two prefixes or two options. We can use the well-known prefix, that's the 64:FF9B/96, or you can use a network-specific prefix, whereby you allocate a prefix from your own block, which will be used for the purpose of NAT64. So let's look at the elements. Yeah, and of course it works in conjunction with DNS64. We'll just look at how the pieces fit in together in a short while. So if you look at the elements, you have your V6 only client, V4 only server, and then you will require the DNS64 resolver and the NAT64 translator. So how does it work? So we talked about DNS64, right? So what DNS64 does is, remember the client is V6 only. So it's going to send a request for a code A record. I'm trying to access the V4 only website, right? So it's going to make the query. Then the server is going to synthesize a code A record and sort of like fool the client that it's communicating with a V4, with a V6 only server. So let's look at how it works all together and then we can understand. So in this illustration, it's all numbered. So first thing, the client sends a query trying to connect to example.com, right? Which is the web server over there on the top right. So that's the web server, right? So first thing, send a query to DNS for example.com. DNS sends, checks, it looks for this domain name, right? Example.com, we get back an IPv4 address. So remember, the client is V6 only. It sends out a query expecting to get back a code A record. And because we don't have an code A entry in DNS, so DNS is going to synthesize based on the V4 address that it gets. So based on 192.0.21, it's going to synthesize using, remember the well-known prefix, right? Which we talked about, 64FF9B, or you can even use your own prefix, the network-specific prefix. So it's going to synthesize a code A record and then convert the last 32 bits, the 32 bits of the IPv4 address, convert it to hex. Some implementations will convert it, others will not. We'll just have the V4 address. And then the next thing is the client now having the IPv6 address, the synthesized address, right? So it's going to send the packet to the NAT64 device. Then the NAT64 device is also aware of this prefix, right? So once it gets the packet, it's going to strip off the last portion and translate that IPv6 packet to IPv4, translate the headers, remember what we talked about, translate the headers and then translate the addresses and send the packet to the server. Then the answer, the reverse happens, comes back as V4. The NAT64 is going to translate the headers, translate the addresses, and then send back the packet as an IPv6 packet. So essentially, that's how NAT64 works in combination with DNS64, but it has pros and cons, right? So there's pros. You have less IPv4 addresses that are going to be used. Remember, you can only just have like minimal IPv4 addresses allocated to for translation purposes. And then subscribers, of course, will share many addresses, and there's no limit in the number of ports per user. And because you have lower address requirements, you're going to have lower OPEX and CAPEX. But the biggest downside is lack of support for V4. The clients it just does V4, nothing else. Not V4, V6. V6 only to V4. So you can't use this maybe from V4 only perspective to something else. So it works from V6 to V4 perspective. And then it doesn't work with literal addresses. Reason being, DNS64, right? It's pegged on DNS64. You must send a query and then DNS64 is going to do the synthesis. So if you are using literal addresses, if you type in the address 192.this.this.this, it's not going to work. So
Bashir,
yes,
if you allow me to explain something so it's more clear, because it's also important for the next one.
yes.
Why we say there is no limit in the number of ports per subscriber, and why we say that NAT64 does a more efficient usage of IPv4 addresses. The explanation is simple. In the other protocols that we mentioned before, we already said that we have to share the IPv4 addresses among customers by limiting the number of ports. For example, you use one IPv4 address for 30 customers and allocate 2,000 ports per customer, okay? So even if one of those customers is using only 300 ports, you are wasting the rest of the 1,700 ports, okay? If you have allocated 2,000. Because it's not dynamic, it's a predefined for each customer. In the case of NAT64, the allocation is always dynamic. So if one customer needs 300 ports, he will get on the fly 300 ports. If another customer needs 3,000 ports, he will get on the fly 3,000 ports. So that means that the utilization of the addresses, of the IPv4 addresses, is always as efficient as possible. That's the reason for that. And of course, that means you need less IPv4 addresses. So that reduces your CAPEX and also your operational expenses. That's basically it.
Yeah. So thank you for the clarification. So of course, as Jody mentioned, right? So NAT64 plays a big part in 464 XLAT because 464 XLAT combines stateful and stateless translation. And then it has minimal IPv4 requirements. I think we've just mentioned this right now. And then it has two components. I'll show you how all these components fit in together in a short while. But it has two components, the PLAT, which is stateful. So these are the provider end, the provider side translator, and then the CLAT. So these are the customer side translator. And then usually the CLAT can also be in a user device. So that's your phone. So most of the implementations, Android, iOS, you'll have a CLAT in it. So let's look at how it fits in all together. So how it works. So similar to our previous scenarios, right? So your provider network is going to be V6 only, right? And then V6, if someone is communicating via V6 only, no translation is going to happen. So the packet is forwarded via v6. So if you have v4, so the first thing that's going to be done is there's going to be a translation from your private IPv4 address to another IPv4 address. So let's say your source is 192.168.12. Your destination is 198.51.101, right? So the CLAT is going to translate your v4 address, both of them. So it's going to translate the source by using a prefix that is assigned for this task, right? So in this case, it's 2001 db8 AA, and then appending the IPv4 address at the end. And then the destination, the same thing. The packet is moved inside the core of your network as a v6 only packet. And then the PLAT is going to do the translation again, right? So it receives the IPv4 packet, and then based on the prefix, we'll have a pool, right? So we have a NAT pool. It's going to look at the last 32 bits, and then it will know that this packet is coming from 192.168 that, and then heading over to 198.51.100.1. So the pillar does the translation and then sends the packet as v4. And then the same thing applies coming back. So this PLAT needs to be, it's stateful, right? It needs to maintain the state of the connection that was done. So that's the IPv4 address plus the ports. So basically that is how 464 XLAT works. And the comment here, this is the only solution for cellular networks. And maybe Jody, since you have operational experience deploying 464 XLAT, as you talk about the pros and cons of 464 XLAT, so can you also tell us why 464 XLAT is the only solution for cellular?
Yeah, actually, 464 XLAT, let's say, when NAT64 was invented, it was mainly considered for cellular networks, okay? Then they discovered the problem that we mentioned before, that it don't support literal IPv4 addresses, and it don't support applications that use older socket APIs, okay? So because that was discovered in the first deployment of NAT64 for cellular networks, which was in US, in T-Mobile, is one of the bigger providers of cellular services in the world. They worked, actually one of the engineers in T-Mobile worked in 464 XLAT. And they decided basically that they don't need any other protocol in cellular networks because this one, 464 XLAT, is resolving all the problems. So if it's resolving all the problems and has no disadvantages, why looking for something else, right? It's easier to have a single standard solution than having different phone vendors using different ones and then making the networks more complex. Now, many people believe that 464 XLAT is only for cellular networks. That's not correct. 464 XLAT is for both broadband wireline and cellular networks, okay? And in fact, there are deployments in the world for both cellular, broadband with cellular, and broadband with DSL, GPON, cable, whatever. Now, of course, 464 XLAT, as I just mentioned, resolves the two problems that has NAT64 with the literals and the socket APIs. So everything works with 464 XLAT. The main disadvantage of NAT64 alone, without 464 XLAT, is of course that the clients need to support IPv6. And that's not possible because you may have all systems like an accounting system in an office for a bank that it's only using IPv4, and then you cannot use that with NAT64 alone. But with 464 XLAT, it will work because it keeps dual stack in the VLANs for the clients, right? For the users. Now, another advantage of 464 XLAT is that in the case of NAT64, you really need to have DNS64 as well. But in the case of 464 XLAT, DNS64 is optional. And the advantage of having DNS64 optional is that DNS64 can break DNSSEC. It don't happen many often, but sometimes it may happen. The number of times DNSSEC is being broken by DNS64 is so tiny that it's not a big problem in general. But the advantage of 464XLAT is that you can just use 464XLAT without the DNS64. Okay, so that will definitively solve the problem for you. I am author of a couple of documents in ITF. I can provide later in the chat the reference to those documents that explain all this in detail. Now, another important thing is that CLAT, the protocol that allows 464XLAT to work in the client part of the network, is already available since many, many years ago in Android. Is also available in Windows for mobile. And in the case of Apple, Apple initially took an alternative approach. Apple asked in 2016 that all the applications that want to be in the App Store, they need to support IPv6 only. So Apple don't have this problem, don't need the CLAT. However, what Apple did about 4 years ago to offer better support is that when you are running tethering in a cellular Apple iPhone, they enable the CLAT for the tethered devices. Okay, so that means that the CLAT is also available if you are using your iPhone as a router for a network, or if you are using any device using offering connectivity via the cellular interface in an iOS Apple device. So yes, the disadvantage may be it may break DNSSEC, but in reality, this is not happening. So it's not a big problem. And in part is because unfortunately, DNSSEC deployment is not so big. And the solution is very simple. If you deploy DNSSEC, at least make sure that you have also IPv6, so then you don't break DNSSEC. Okay, so simple solution for that. If you are a provider of something that uses DNSSEC. And my last comment is about the well-known prefix or the network-specific prefix. I have done several deployments, some of them small trials, some of them bigger deployments. I will mention one of them right now. And the conclusion was when we do the trials and the testing that it don't make sense to use a network-specific prefix. In 99.9% of the cases, the well-known prefix works perfectly and you don't need to use anything else. Now, the bigger deployment that we are doing is for 25 million subscribers with 464XLAT, and they have GPON, DSL, and cellular, okay? So it's not a small project, it's a big project, and we have been doing a testing for already 1 year or so, and everything is working fine. We tested thousands of applications and things, and nothing was broken. So if you compare 464XLAT with the other protocols that we have seen before, I really think it's the best solution for any network, basically.
Yeah. And I had the chance to experience 464XLAT, one of the providers back in my country. So they
What is
deployed...
your country?
Maybe it should remain a secret, right?
Is Kenya, maybe?
Let it be a secret for now, right?
Okay,
but
okay.
it's yeah, it's one of the biggest service provider. And one day I was looking at the APN settings, and I remembered in Kampala, one of the guys talked about them deploying V6, right? And then I decided to go V6 only for one weekend, and it was awesome. I didn't experience any, I didn't even notice it. So
exactly.
I can say
that's the idea,
yeah.
that the customers don't notice anything. That's it.
Yeah, yeah. So looking at the traffic treatment scenarios as we wind down, right? So how 464XLAT treats the traffic. So we've seen that if you're communicating from V6 to V6, that will be end-to-end V6. No translation is done, right? If your server is V4 and your application or host is V6. So this is V6 to V4, right? So you only do stateful translation, and the pilot is the one that's going to be involved in this, right? Because remember, the pilot does NAT64, and you're just doing, you have V6 on your end, right? So it's going to be one stateful translation. But if you're doing IPv4 to IPv4, you'll need double translation. So from, even as the name suggests, implies, from V4 to V6 in the core, V6 only, and then from V6 to V4. So these are some, yes.
You have three cases, okay? The last case is actually the one that happens when you have literals. For example, you type 1.1.1.1 at the browser, okay? So that only happens in real networks. The first case will probably be more than 75% of the traffic. The second case will be 24% of the traffic. And the last case will be only 1% of the traffic. That's data from real networks. And in some cases, when the network is much more residential traffic, instead of 75%, it can be up to 90%. Okay, why? Because all the traffic for residential customers is like Netflix, YouTube, Facebook, things like that. And all that already is IPv6 ready. So most of the traffic in a network with residential customers, majority of residential traffic, will be IPv6.
So thank you for that, Jody, as usual. So as we near the end of the session, so which transition technique should you use? And again, as I mentioned earlier on, right now you should have a rough idea on these various transition techniques. But like we said, there's no one size fits all, right? But we can just give you some recommendations. So typically, right now you should have your network running V4 only. Maybe if you've not even started deploying V6, right? And then you want to move to V6, right? So that you can be able to access the V6 internet. Typically, maybe you start from dual stack, an easy entry point, but you'll start deploying these transition techniques that we've talked about. But the end goal is V6 only with V4 as a service. So, and this will make it easy for you to transition to V6 only in the future. So let's look at a summary. So if you are to be asked, Jody, right?
Okay,
So
let's try to fill the table together.
Yes.
If you have cellular customers, you can only use 464X LAT. So very simple decision, right?
Yeah.
Now, if you have broadband and cellular, do you think it makes sense to use two different protocols? Obviously not. You want to have your network with a single protocol and keep it simple. Let's suppose you are only a broadband provider, but you offer via third-party provider a cellular backup. Do you think it makes sense to offer two different protocols? Obviously not. Now, do you want to have the risk to invest in devices like carrier grade NAT for DS Lite? And if you have residential customers using PlayStation to be filtered, to be blacklisted? Obviously not. So in general, in all the cases, I mean ISP, never mind is broadband, wireline or cellular, my recommendation is 464X LAT is the only one that makes sense. Now, what about enterprise? Well, an enterprise should keep as much as possible dual stack inside of the LANs. I don't think it makes sense to recommend DS Lite or MapE or 464X LAT in an enterprise network. Okay. However, This is talking only from inside of the network. Of course, the ISP neither is, never mind is broadband or cellular, will use some protocol like maybe dual stack, but maybe also 464X-LAT. When an ISP need to provide dual stack, only to to corporate customers that have the need to expose public IPv4 addresses to the internet. But today, this is less and less common because most of the people, most of the companies are using cloud services or data centers to host their services. So normally, if you are an ISP providing service to residential and corporate, normally you will be able to work perfectly with 464X-LAT for all the customers. Never mind they are enterprise or residential. However, there is also ways to configure in the NAT64 specific IPv4 addresses for some customers. So even with 464X-LAT, you can still offer dual stack to some customers. So that's my recommendation. I know that vendors, because they have better solutions with DS Lite or MapE or MapT, they want to sell you bigger boxes, more expensive boxes. But of course, I don't recommend that because I am not working for any vendor.
Yeah. Yeah. So thank you very much, Jody. And at least this gives an insight for the ones who want to apply these transition techniques in their networks. So I will finalize by looking at the last thing, which is auditing. I won't spend much time here because we've done a session on auditing. I'll just mention the importance of why you need to check. From the transition techniques that we've looked at, you'll notice that we have, when you talk to 464X-LAT, you'll have your PLAT, you'll have your CLAT. So you need to check that the device that's going to be handling the stateful translation, it should have the necessary features or should support what you want to implement. And then for the CLAT, for example, you need to look at the CPAs, whether you have proper support for the CLAT. So the steps that you'll go through is identify the devices and then determine the required features. PLAT, CLAT, NAT64, NAT64, DNS64. So determine the required features and then look at the feature support. There are many ways you can look at the feature support. You can use the data sheets. You can use the feature navigators online for these various vendors. And then, of course, you need to make a decision on whether the next step of action. So are you going to get maybe a VM to do that functionality? Are you going to upgrade the box, or are you going to get external providers to give you the service? And basically this is the end result. After doing your research, you're going to make a decision and you'll research using the feature navigators and data sheets or all other resources. So I think finally, Jody, the parting shots. So I think it's been fruitful for all of us. I hope at least we have an idea on the path that we need to take, right? Right now you might be V4 only. So it makes sense to at least start deployment. And again, we should not have excuses, right? As much as we've told you 464X-LAT and all these transition techniques, there's some things that you can start doing right now to help you to migrate to IPv6. And as Jody mentioned, these transition techniques are only short-term. So Jody mentioned of the scenario whereby there's a provider who deployed 464X-LAT and 75% of the traffic was IPv6 only. So this tells you a lot, right? And only 24% of the traffic was translated statefully. And 1% of the traffic used the CLAT. So this is the literals and the rest, right? So it tells you that these transition techniques are just temporary. And in the long run, we should be able to get to V6 only. So Jody, what are your parting shots?
Yeah, One important thing here is that when you enable IPv6 only, which IPv4 as a service in a network, it happens overnight. So it's not like you get the first day 1%, the second day 2%. No, if you enable IPv6 in a customer, that customer will switch all the traffic to IPv6. Well, not all, maybe 75%, maybe 80, maybe 85, depending on which applications he's using. If he's using more Netflix than nothing else, it will be 100%, right? So that happens overnight. And that's very important because that proves you that what you are doing is right. The other thing I want to mention is that if you want to set up a lab with 464X-LAT, you just need virtual machines. You don't need physical boxes. So you can do even in your home. You can run a virtual machine which an open source implementation of NAT64, which is called a Joule. Okay, I will write it in the chat so everybody can get it. Joule.mx, I think, is the website. It's done by Nick Mexico, so somehow like the equivalent of Afrinic, but for Mexico, and it's open source. And Joule works fantastic, and you can do both the CLAT and the NAT64, which is the PLAT, with Joule. But you have also with regular routers in the market, you can use OpenWRT. I am sure many people know OpenWRT. I am writing it in the chat as well. Oh, sorry, in the chat I need to do this, Joule.mx and OpenWRT. I think now everybody can see it. So OpenWRT is an open source implementation for CPEs, for routers that we all have at home. And you can run the CLAT in OpenWRT very, very easily. So you can test yourself without spending any dollar for this testing. So it's quite simple. So I encourage everybody to try that. And I think that's it.
Yeah, thank you, Jody. So before we finalize, right? So if you need any help deploying V6, so kindly use this link. We'll also share it again in the email. So just use that link and the Afrinic team will be able to help you with your IPv6 deployment. So bit.ly/6deploy en. I think Ola can type it in the chat section also so that we have it. But we also...
Okay, go on. I was going to add something to that, but that's fine.
Okay, yeah. So do you have any questions before we leave, we finalize?
I have copied in the chat also a couple of documents from ITF. One of them is a draft, but it will become it's already selected as an ITF official document, so it will be soon an RFC. Well, soon. Sometimes it takes months, sometimes years. You never know. And I have copied also a RIPE 690, which is a reference for addressing plans and things like that for IPv6. I think it's worth reading those documents for everyone.
Okay, we'll also share them in the materials.
Perfect, thank you.
Yeah. So if there's no other question, I'd like to thank you all. Thank you, Jody, for taking the time to be with us. And I hope that you've learned something for the participants, right? And you're going to push the deployments in your various networks. So don't wait to start in the future or think about the big plans. You can just do it step by step, and we're always here to guide you. So with that, I'd like to thank you all. And if no questions, Ola, over to you.
As usual, happy to help. Thank you very much for everybody to participate.
Okay, there's a question in the chat about the slides. So you're going to get another email after the one you just got now, about 15 minutes ago, which you have to complete an end of event survey, and then you have access to the video, the recording of this session, and the slides. Okay.
Okay. And one more thing, please give us feedback, right? It's the only way we know how to improve ourselves and know the relevant things that we're supposed to do, right? So we can't do that without feedback from you. Ola, over to you.
That's fine. So Also, keep an eye on our learn.afrinic.net for our next upcoming event, because we have these webinars once a month. There'll be another topic coming up on May 20 or 20th May, if I'm correct, on RPKI. All right. So thank you very much.
Okay. Thank you. Bye.